Syntax and basic constructs. JavaScript syntax refers to the set of rules and guidelines that define how to write JavaScript code. Basic constructs include variables, data types, operators, and control structures. Understanding these foundational elements is crucial for programming in JavaScript. In the provided code snippet, we declare a variable named message using the var keyword, which is one way to declare variables in JavaScript. This variable is assigned a string value, hello world. The console.log function is then used to print the value of the message variable to the console. This illustrates two basic constructs, variable declaration and output to console. Variables hold data which can be manipulated, and console.log is a simple way to view program output. Data types and variables. In JavaScript, data types categorize values into different types, allowing for operation suitability and memory allocation efficiency. Variables are containers for storing data values. JavaScript supports dynamic typing, which means you don't need to declare a variable's type explicitly. In the code, let is used to declare variables. Message is a string data type denoted by text enclosed in quotes, used for storing sequences of characters. Score is a number data type, used for integers or floating point numbers. IsUserLoggedIn is a Boolean data type representing logical values, true or false. JavaScript automatically infers the data type based on the value assigned, showcasing its dynamic typing characteristic. Operators. In JavaScript, operators are used to perform operations on variables and values. Common types include arithmetic, assignment, comparison, logical, and more. They are the building blocks that allow us to manipulate data, compare values, and perform mathematical calculations. In the provided code, we're using arithmetic operators. Plus adds a and b together, resulting in sum being 15. Nas subtracts b from a, making difference for 5. Sor multiplies a and b, with product being 50. Slash divides a by b, and division results in 2. Each operator performs a specific mathematical operation, allowing us to manipulate and evaluate numerical values efficiently. Control flow, if-else, switch, loops. Control flow in JavaScript allows you to dictate how your program runs under different conditions or how it repeats certain tasks. The if-else statement executes code based on a condition. The switch statement is used for multiple conditions. Loops, such as for and while, repeat code a set number of times or while a condition is true. The if-else statement checks the age variable. If it's 18 or over, it logs you are an adult. Otherwise, you are a minor. The switch statement checks the fruit variable and logs a message based on the case that matches its value, with a default for unmatched cases. The for loop initializes a variable I to 0, and as long as I is less than 5, it increments I by 1 on each loop, logging I to the console each time. The while loop initializes a variable j to 0 and runs as long as j is less than 3, incrementing j by 1 on each loop and logging j. Functions. Functions in JavaScript are one of the core building blocks. A function is essentially a set of statements that performs a task or calculates a value. Functions allow for modular code, easy maintenance, and code reuse. Let's take a look at a basic function declaration and invocation. In the provided code, we define a function named greet that takes one parameter, name. Within the function, we compose a greeting using the parameter and output it to the console using console.log. Finally, we call the function with the argument Alice, resulting in the output, hello Alice. This demonstrates how functions can be declared, parameters handled, and functions called with arguments. Scope and hoisting. Scope determines the accessibility of variables, objects, and functions from different parts of the code, essentially where these variables or functions can be accessed. There are two types of scopes in JavaScript, global scope and local scope. Let's look at an example to understand better. In this code, the variable x is declared in the global scope, making it accessible anywhere in the script. The variable y, however, is declared within example function, making it only accessible inside that function. Accessing y outside its local scope leads to a reference error. Arrays. Arrays in JavaScript are used to store multiple values in a single variable. They can hold items of any data type and are zero-indexed, meaning the first item is accessed with an index of 0. Let's explore how to create, access, and manipulate arrays. This code demonstrates basic operations with an array. First, we create an array named fruits containing 3 strings. Accessing the first element, apple, uses fruit0 because arrays are 0-indexed. The push method adds a new element, durian, to the end of the array. We then print the length of the array, which is now 4. Finally, we replace the second element, banana, with blueberry by directly assigning a new value to the index 1 position. The final console.log shows the updated array. Objects. In JavaScript, objects are collections of properties where each property is defined as a key-value pair. Properties can be of any data type, including numbers, strings, arrays, functions, and even other objects. Objects offer a way to organize data and functionalities under a single entity, making it easier to manage and operate on related sets of information. In this example, we define an object named person with 3 properties: name, age, and is employed. Each property has a value associated with it, which could be a string, a number, or a boolean, respectively. The console.log statement then accesses the name property of the person object using dot notation, which outputs John Doe. This illustrates how we can create an object, assign properties with values, and access these values. JSON. JSON, which stands for JavaScript Object Notation, is a lightweight data interchange format. It is easy for humans to read and write, and easy for machines to parse and generate. JSON is a syntax for serializing objects, arrays, numbers, strings, booleans, and null. It's widely used in web applications for sending data from server to client, and vice versa. The code snippet demonstrates 2 key operations with JSON in JavaScript: JSON.stringify and JSON.parse. JSON.stringify takes a JavaScript object, in this case, person, and converts it into a JSON string, which is then logged to the console. This is particularly useful when we need to send the object data over a network or store it in a file. JSON.parse does the opposite. It takes a JSON-formatted string, previously generated by JSON.stringify, and converts it into a JavaScript object. This is useful for retrieving and using data received as JSON from a web server or local storage. Through these methods, JSON facilitates the exchange and storage of structured data. Error handling and debugging. Error handling and debugging are essential skills for any JavaScript developer. Proper handling ensures that your program can gracefully recover from unforeseen situations, while debugging helps locate and fix issues in your code. JavaScript's primary mechanism for handling errors is the try-catch block, which allows for executing code that may fail and specifying a response if an error occurs. Console methods, like console.log, are indispensable for debugging, enabling you to inspect values and track code execution. In the provided code snippet, we start with a try block, attempting to log a message, and then deliberately throw an error with a custom message. The catch block immediately follows, catching and handling the thrown error by logging its message. Lastly, the finally block contains code that executes regardless of whether an error was thrown or not, indicating that parts of your program can run even after handling errors. This pattern is a fundamental aspect of error handling in JavaScript, allowing developers to anticipate, catch, and respond to errors without disrupting the entire program flow. ES6+, let and const, arrow functions, template literals, spread REST operators. In ES6, let and const are introduced for block-scoped variable declarations. Let allows you to declare variables that are limited in scope to the block, statement, or expression where they are used, unlike var, which is function-scoped. Const is used to declare variables meant to be constants which cannot be reassigned. In this example, x is declared with let and y with const, inside an if block. This means x and y are only accessible within this block. Attempting to access them outside of it would result in a reference error. Additionally, since y is a constant, attempting to reassign it, e.g. y equals foo, inside the block would also lead to an error. This example prints hello world to the console. Asynchronous JavaScript promises async await. Asynchronous JavaScript allows functions to run in parallel, improving app performance and user experience. This is crucial for operations that might take some time, like fetching data from a server. JavaScript handles asynchronous operations through promises and async await syntax, making code cleaner and easier to understand. In this code, fetch data returns a promise that resolves after 2 seconds, simulating a data fetch operation. The async keyword before a function declares it as asynchronous, allowing the use of a wait inside it, which pauses execution until the promise is resolved. When getData is called, it waits for fetch data to complete before logging data fetched to the console. This demonstrates how async await makes handling asynchronous operations straightforward, enhancing code readability and maintainability. Git basics: init, add, commit, push, pull. Git is a version control system that allows multiple developers to work on a project without interfering with each other. It tracks changes in source code during software development. Here, we will cover the basics: initializing a Git repository, adding files to the repository, committing changes, pushing changes to a remote repository, and pulling updates from the remote repository. 1. Git init initializes a new Git repository locally in your project directory. 2. Git add filename stages a file to the repository, making it trackable by Git. Replace filename with the actual name of your file. If you wish to add all files in the directory, you can use git add. 3. Git commit m initial commit captures the current state of the project into the repository with a descriptive message. 4. Git push origin master sends the committed changes to the remote repository defined as origin on the master branch, though main is now more commonly used. 5. Git pull origin master retrieves updates from the remote repository and merges them into the local repository. Branching and merging. Branching in Git allows developers to diverge from the main line of development and work on changes or new features without affecting the main branch. This way, development can proceed in a parallel rather than linear manner. Merging is the process of integrating changes from one branch into another, typically from a feature branch back into the main branch, to bring the project up to date. In this example, Git branch feature X creates a new branch named feature X. Then, Git checkout feature X switches to this newly created branch, allowing you to work on this isolated environment. After making changes and committing them to feature X, you switch back to the main branch using Git checkout main. Finally, Git merge feature X merges the changes from feature X into the main branch, combining the histories and changes of both branches. Working with remote repositories. Remote repositories are versions of your project that are hosted on the internet or network somewhere. You can collaborate with others on your project by pushing data to and pulling data from these remote repositories. Let's start with connecting a local repository to a remote server. The first command, git remote add origin http:/github.com/user repo.git, is used to add a new remote repository under the name origin, pointing to the URL provided. This URL is where your repo will be pushed on GitHub or another online host. The second command, git push u origin master, pushes your local repository's commits to the remote repository on the master or main branch for the first time, setting it to track the remote master branch from then on. The -u flag sets the remote as the upstream for your branch, allowing future pushes or pulls without specifying the branch name. Conflict resolution. During collaborative development with Git, conflicts can arise when merging branches if changes to the same lines of code or sections are made in parallel. Git will highlight these conflicts and halt the merge, allowing the user to manually resolve the issue. The following example demonstrates a simple conflict and its resolution. In this code snippet, a conflict has occurred during a merge. The current branch, denoted by head, has var x equals 1, on the same line where the feature branch has var x equals 2. To resolve this conflict, one must decide which version of var x to keep, or perhaps merge the changes in a suitable manner, and then delete the conflict markers, iwt, and. Once resolved and the markers are removed, the file can be saved and Git commands can be used to continue the merge process. Best practices. Adhering to best practices in Git helps manage and maintain projects efficiently, especially when working in teams. It ensures a clean, understandable history that can be followed by anyone who reads it. The code snippet illustrates 2 best practices, meaningful commit messages and feature branching. The commit message succinctly describes what the commit does, making the project history readable and understandable. Creating a new branch for developing a feature isolates changes from the main codebase, allowing for safer experimentation and easier code reviews before merging into the main branch. This practice helps in maintaining a stable main branch and facilitates continuous integration and deployment. HTML5 Elements, Attributes, Forms, Semantic HTML. HTML5 is the latest evolution of the standard that defines HTML, introducing numerous elements, attributes, and types designed to make web development more intuitive and effective. It emphasizes semantic HTML, which helps with SEO and accessibility, and it brought about more user-friendly forms. Let's explore these concepts through a basic form example comprising various HTML5 features. The code shown is a simple HTML5 document containing a form. It begins with the doc type declaration to specify HTML5. Elements such as head, title, and body lay the foundational structure of the web page. The form tag encapsulates input elements showcasing forms in HTML5. The use of label tags associated with respective input fields through the for attribute improves accessibility, indicating what each input is for. Input fields like text and number demonstrate the variety of data types HTML5 supports for user input. This code example encapsulates the essence of HTML5 elements, from structural elements to form controls, highlighting how HTML5's advancements facilitate more semantic and interactive web page creation. CSS3, Selectors, Box Model, Flexbox, Grid. CSS selectors are used to select the HTML elements you want to style. We can divide CSS selectors into several categories, such as simple selectors, select elements based on name, ID, class, combinator selectors, select based on a specific relationship between them, and pseudo-class selectors, select elements based on a certain state. In this example, the div.className selector targets any div element with a class of class name and applies the style rule to change the text color to red. The period dot before class name signifies that it's a class selector. Responsive design, media queries, mobile first. Responsive design allows websites to adapt to the device's screen size, providing an optimal viewing experience. The mobile-first approach involves designing for smaller screens first, then scaling up. Media queries are a key tool in implementing responsive design, as they apply CSS rules based on device characteristics. This code snippet demonstrates the use of media queries for responsive design. It sets the body font size to 14px for screens that are at least 320px wide, catering to mobile devices. For screens that are 768px wide or wider, typically tablets and desktops, the font size is adjusted to 16px. This scaling up of font sizes from mobile to desktop illustrates the mobile-first concept, ensuring the content is accessible and readable across different devices. JavaScript DOM manipulation. JavaScript DOM, Document Object Model, manipulation allows you to dynamically change the contents and appearance of a web page without needing to reload the page. It involves creating, modifying, or removing elements and attributes in the HTML document. In the provided code, document getElementById, demo, selects the HTML element with the ID demo. The .inner HTML property is then used to modify the content of this element. The string hello, world replaces whatever content was previously inside the demo element. This is a fundamental concept in DOM manipulation, showing how easily JavaScript can change the content of HTML elements on a web page. Event handling. In the context of web development, events are actions or occurrences that happen in the system you are programming, which the system tells you about, so you can respond to them in some way if desired. Examples include changes in the state of one of the system's components, user interactions such as clicks, keyboard input, etc. Event handling refers to the mechanism that takes care of these events. It's how we can execute a piece of code in response to a user action. This block of code demonstrates capturing and handling a click event on an HTML element, specifically a button with the ID myButton. When the button is clicked, the anonymous function provided to add event listener is executed, triggering an alert dialog that says button clicked. The add event listener method is an essential part of working with events in JavaScript, enabling you to specify the type of event to listen for, click in this case, and the action to take when that event occurs. Fetching data, AJAX Fetch API. Fetching data from a server is a common task in web development, allowing dynamic content to be displayed without reloading the page. Two common methods include AJAX, asynchronous JavaScript, and XML, with the XML HTTP request object, and the newer Fetch API, which uses promises for a cleaner, more flexible approach. This code utilizes the Fetch API to retrieve data from https ap.example.com/data. The fetch function makes a network request to the URL and returns a promise. The first .then method is used to convert the response into a JSON object, with the second .then handling the actual data received. If the request fails for any reason, the .catch method catches the error, allowing for error handling. Front-end frameworks, React.js introduction, components, state management, routing. React is a popular JavaScript library for building user interfaces, particularly single-page applications where you need a fast, interactive user experience. React uses a component-based architecture, making it easy to reuse code. This code snippet introduces a basic React component named welcome that accepts a name prop and renders a greeting message. Using React DOM.render, we then display this component within the root div of our HTML, showcasing React's simplicity and component-based approach. State management libraries, Redux, Context API. State management is crucial in React apps to maintain data or UI state across components. Redux and Context API are popular tools for this purpose. Redux offers a central store for state that can be accessed by any component, making it easier to manage complex state interactions. Context API, introduced in React 16.3, provides a way to pass data through the component tree without having to pass props down manually at every level. In the provided code, we use the Context API to create a global state management solution similar to Redux, but with simpler setup. First, createContext is used to initialize a new context object. The state provider component wraps our app's components, allowing any child component to access the state via the state context. It utilizes the useReducer hook for updating state, offering Redux-like reducer functionality. The useStateValue custom hook utilizes useContext to allow components to easily access the global state. This setup is ideal for small to mid-sized applications where Redux might be considered overkill. Front-end build tools, Webpack, Babel. In modern web development, tools like Webpack and Babel play crucial roles in creating efficient, optimized web applications. Webpack is a module bundler that allows us to bundle multiple JavaScript files into one, reducing load times. Babel, on the other hand, is a JavaScript compiler that lets us use next-gen JavaScript today. It does so by converting ECMAScript 2050 Plus code into a backward-compatible version of JavaScript that can be run by older JavaScript engines. The provided code is a basic Webpack configuration file. It specifies an entry file, app.index.js, where the bundling process begins. The output instructions tell Webpack to bundle the code into a single file named bundle.js, placed in a dist directory. The module section outlines rules for which files to apply transformations to. Here, it's configured to use Babel Loader for all .js's files, excluding those in Node modules. The Babel Loader uses Babel to transpile ES6 and beyond code into ES5, ensuring compatibility. This setup allows developers to write modern JavaScript comfortably, knowing it will work across various environments. Testing, Jest, React testing library. Testing is essential in ensuring the reliability and correctness of your code. Jest is a delightful JavaScript testing framework focused on simplicity, and React testing library provides light utility functions on top of React for allowing you to more easily write tests. We will look at a simple component test using both tools. This code snippet demonstrates a basic test for a React component using Jest and React testing library. The render method from @testing_library/React is used to render the app component in a testing environment. Then, we use screen.getByText to query the rendered output for any text that matches the regex pattern /learnReact/I, which signifies case-insensitive matching. Finally, expect and .b in the document are used to assert that the queried element is indeed part of the document. This simple test ensures that the app component renders a link or text containing Learn React. Node.js basics. Node.js is an open-source, cross-platform JavaScript runtime environment that executes JavaScript code outside a web browser. It enables developers to use JavaScript to write command line tools and for server-side scripting, thus running scripts server-side to produce dynamic web page content before the page is sent to the user's web browser. Here, we'll create a simple Node.js script that outputs "Hello World" to the console. In this code snippet, we utilize console.log, a built-in Node.js method used for printing messages to the console. When the script is executed, it displays "Hello World" in the terminal. This demonstrates Node.js's ability to run JavaScript outside of a web environment. The simplicity of the command illustrates the ease with which Node.js facilitates server-side scripting and showcases how JavaScript code can be executed on a server. NPM, Node Package Manager. NPM stands as a cornerstone for managing packages and dependencies in Node.js environments, enabling developers to install, share, and control libraries or tools for their projects. It connects to an expansive registry of JavaScript packages, allowing for efficient project development and deployment. This command is used to install the Express framework, a popular choice for building web applications in Node.js. When executed, NPM searches the registry for the Express package and downloads it along with its dependencies into the Node modules directory of your project. This process makes Express available for import and use within your application. It's a fundamental example of how NPM facilitates the addition of external libraries to enhance project capabilities. Express.js, creating a server, routing, middleware. Express.js is a lightweight web application framework for Node.js, designed for building web applications and APIs. It simplifies the server creation process that's native to Node.js and provides an easy way to handle requests and routes. This code initializes the Express module and creates an app object, which represents the Express application. It sets up a basic route for the root URL that sends a response, "Hello World," to client requests. Finally, it listens on port 3000 for connections. The app.get method is used for handling GET requests to the server, providing a simple way to define routes. When a request matches the specified path, the callback function is executed. The listen method starts the server on the given port. RESTful API design. RESTful API design refers to the architectural style of developing web services that emphasize communication through the use of stateless operations on resources. The core concept revolves around using HTTP methods in a way that is reflective of the operation being performed, such as GET for fetching data, POST for creating, PUT for updating, and DELETE for removing data. In this code snippet, we're defining two routes in an Express.js app. The first route listens for GET requests on /API/resources, indicative of fetching and returning a list of resources. The handler function would contain logic to do so. The second route listens for POST requests on the same endpoint, intended for creating a new resource. Here, the handler function would involve logic to add a new resource to the database or storage. This adherence to using HTTP methods for specific actions on resources is a fundamental principle of RESTful API design. Authentication and authorization, JWT, OAuth. Authentication and authorization are crucial for securing your application. Authentication verifies who the user is, while authorization determines what resources a user can access. JWT, JSON Web Tokens, is a compact URL-safe means of representing claims to be transferred between two parties. OAuth is an open standard for access delegation, used to grant websites or applications access to their information on other websites, but without giving them the passwords. In this code snippet, we demonstrate a basic usage of JWT for authentication. First, we require the JSON Web Token package. Next, we create a token using jwt.sign by passing the user's unique identifier and a secret key. The token is set to expire in 2 hours. Then we verify the token using jwt.verify, checking if it's valid by comparing it with the secret key. If the token is not valid, an error is logged. Otherwise, the decoded token is logged, confirming its validity. Database integration, MongoDB, Mongoose for MongoDB. Integrating databases is a crucial aspect of backend development, and MongoDB is a popular choice due to its flexibility and ease of use. Mongoose is an object data modeling (ODM) library for MongoDB and Node.js that provides a schema-based solution for modeling your application data. It includes built-in typecasting, validation, query building, business logic hooks, and more, making it easier to work with MongoDB. Let's look at a basic example of setting up Mongoose with MongoDB. First, we require the Mongoose package. We then connect to our MongoDB database using mongoose.connect, specifying the database URL and options to ensure compatibility and use of the new server discovery and monitoring engine. After connecting, we define a simple model for our data, a cat in this case, with a single field name. We then create an instance of our cat model named Kitty with the name Zildjian and save it to the database. Once saved, a confirmation message is logged to the console. This process involves defining how our data should be structured, cat model, creating a new record, Kitty, and persisting this record to the database, kitty.save. Error handling in Express. Error handling is a critical part of developing robust web applications. Express, a popular Node.js web application framework, provides a streamlined way to catch and manage errors that may occur during the request-response cycle. Proper error handling helps maintain a good user experience and aids in debugging. This snippet is an example of a basic error handling middleware in Express. It's defined using app.use. The middleware takes 4 arguments: the error object, the request object, rec, the response object, res, and the next middleware function in the stack, next. This particular middleware logs the error stack trace to the console for debugging purposes and sends a generic something broke message to the client with a 500 internal server error status. It's important to place error handling middleware at the end of the middleware stack, ensuring it catches errors from preceding middlewares or routes. Testing APIs. Mocha Chai. Testing APIs ensures that your backend services respond correctly to various requests, help catch regression errors, and guarantee contract adherence between front-end and back-end. Mocha and Chai are popular libraries in the Node.js ecosystem for writing and executing tests. Mocha provides the test framework, while Chai offers assertion functions to validate your API responses. Here, we'll create a simple test for a hypothetical get/users endpoint using Mocha and Chai. The code snippet showcases a test for a get/users endpoint. We start by importing Chai and the Chai HTTP plugin, which allows Chai to make HTTP requests. Next, we import the server from where our Express app is exported. We then instruct Chai to use Chai HTTP. In the describe block, a meaningful description of the test suite, collection of related tests, is provided. Inside it, the it block describes a specific test case, checking if the /users endpoint returns all users. Using chai.requestServer, we make a GET request to /users, and in the callback, we check the response status to be 200, OK, and that the response body is an array. The done callback ensures Mocha waits for this asynchronous operation to complete before concluding the test. GraphQL Basics. GraphQL is a query language designed for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API, gives clients the power to ask for exactly what they need and nothing more. It makes developing APIs faster, easier, and more efficient. Let's dive into the basics of setting up a simple GraphQL server. The given snippet starts by importing Apollo Server and GQL from the Apollo Server package, tools essential for building a GraphQL server. Type.defs contains your GraphQL schema, defined using the GQL temp literal. This schema declares a query type with a hello field, which is a string. Resolvers is an object that defines how the queries in your schema are resolved. In this case, calling the hello query returns the string hello world. Finally, an instance of Apollo Server is created with the type.defs and resolvers, and the server is started. This example sets up a basic GraphQL server that responds to a query for hello with hello world. Server-side rendering. Server-side rendering, SSR, is a technique used in web development where the content of a web page is generated on the server rather than in the browser. This method can provide faster initial page loads, improved SEO, and better performance on devices with slower processing power. Let's look at a simple example using Express, a popular Node.js framework. This Express.js code snippet demonstrates a basic server-side rendering scenario. A server is created using Express. When a GET request is made to the root URL, the server responds by sending HTML content, h1 hello world h1, back to the client. The app.listen function starts the server on port 3000. In a real-world application, the HTML content would likely be dynamically generated based on data from a database or API. However, this example captures the essence of SSR by directly rendering content on the server before sending it to the client. Database basics. In the context of full-stack JavaScript development, databases are essential for storing, retrieving, and managing the data used by both the server side and client side of an application. There are various types of databases, but a fundamental division is between SQL, relational databases, and NoSQL, non-relational databases. Let's start with SQL databases using a basic SQL query. This SQL command is used to retrieve all information from the user's table where the condition, age greater than 18, is met. It's a fundamental example of how data can be selectively fetched from a database, demonstrating the use of select to specify what data to return, from to define the source table, and where to set conditions for the data selection. Understanding these components is pivotal for querying databases effectively. Relational databases, MySQL, PostgreSQL. Relational databases like MySQL and PostgreSQL use structured query language, SQL, for defining and manipulating data. In these systems, data is organized into tables which are related to each other through common fields. Let's explore creating a simple table in MySQL. This SQL statement creates a new table called users in a MySQL database. It defines 3 columns, ID, name, and email. The ID column is an integer that auto-increments and serves as the primary key, ensuring each record is unique. The name and email columns are character strings of up to 100 characters. Additionally, email is set as unique, meaning no 2 records can have the same email. This structure exemplifies how relational databases manage data in a tabular form, allowing for efficient storage, retrieval, and relational operations. NoSQL databases, MongoDB, CouchDB. NoSQL databases, such as MongoDB and CouchDB, provide flexible schemas for storing and managing data. Unlike traditional SQL databases, NoSQL databases can handle a wide variety of data types and structures, making them suitable for dynamic or unstructured data. MongoDB, for example, stores data in BSON, binary JSON documents, while CouchDB uses JSON. Both support CRUD operations, but have different approaches to scalability, consistency, and availability. This code snippet demonstrates how to insert a new document into the products collection in a MongoDB database using the insert1 method. The document being inserted represents a product with fields for name, brand, and a nested object specifications for detailed attributes. MongoDB allows for this flexible structure without predefining a schema. ORM and ODM libraries sequelize Mongoose. ORM object relational mapping and ODM object document mapping libraries like Sequelize and Mongoose, respectively, help developers to interact with databases in an object-oriented manner, abstracting the direct database queries. Sequelize is typically used with SQL databases like PostgreSQL, MySQL, while Mongoose is used with MongoDB, a NoSQL database. In the Sequelize part of the code, we're requiring the Sequelize library, creating an instance of it, and connecting to a MySQL database with a specified database name, username, and password. The dialect option specifies the type of database. In the Mongoose section, we require the Mongoose library and connect to a MongoDB database using its connection string. This abstracts away much of the complexity of database interactions, allowing developers to work with databases using JavaScript objects and methods. Database design and modeling. Database design and modeling involves organizing data according to a database model. The most popular model for web applications is the relational model, which organizes data into tables, relations, of columns and rows. Each table represents a different entity type, and relations between tables are defined by foreign keys. A well-designed database is essential for efficient data retrieval and storage. Let's consider designing a simple database for a blog application. In the provided SQL code, we're creating 2 tables, users and posts. The users table includes columns for user ID, a unique identifier for each user, username, and email. User ID is the primary key, indicating that each value must be unique to identify each record uniquely. The post table is for blog posts, with columns for post ID, user ID, title, content, and publication date. User ID in posts is a foreign key that references user ID in users. This establishes a relationship between the two tables, indicating that each post is associated with a user. This example demonstrates basic relational database design, organizing data into related tables to facilitate efficient data management and retrieval. CRUD operations. CRUD operations stand for create, read, update, and delete. These are the 4 basic functions necessary to interact with any database. In the context of a MongoDB database, these operations can be performed using the MongoDB shell or through a MongoDB driver in a specific programming language, such as JavaScript. Below, we'll look at how to perform CRUD operations using Mongoose, a popular MongoDB object modeling tool designed to work in an asynchronous environment. The code snippet demonstrates the CRUD operations using Mongoose with MongoDB. Initially, it establishes a connection to a MongoDB database named test. The cat model is defined with a single attribute name. For create, a new instance of cat is created and saved to the database, which logs meow upon success. The read operation is performed by finding all document entries under the cat collection and logging them. Update is achieved by finding a specific cat document by its name and updating its name attribute, while delete operation is performed by removing a cat document that matches a given condition. Each operation is asynchronous, and the result or confirmation is logged upon completion. Transactions. In databases, a transaction is a unit of work that is executed atomically and isolated from other transactions. Transactions ensure data integrity and consistency, even in cases of system failures or concurrent access. A transaction typically follows the ACID properties: atomicity, consistency, isolation, durability. In this example, we start by initiating a transaction with begin transaction. Then, we execute 2 update statements to transfer $100 from one account to another. Finally, we commit the transaction with commit. This ensures that either both updates are successfully executed, maintaining the consistency of the account's balances, or, if an error occurs, neither of the updates are applied, demonstrating atomicity. The whole sequence is treated as a single, indivisible operation. Understanding hosts and servers. In the world of web development, hosts and servers play critical roles. A host typically refers to a computer or a network that houses the server, providing the necessary resources for it to operate. A server, on the other hand, refers to software or hardware that provides services to other computers or clients over a network. Understanding how to set up hosts and deploy servers is fundamental in managing web applications. In the upcoming example, we will use Node.js to create a simple server. The code snippet above demonstrates how to create a simple server using Node.js and the HTTP module. We initiate a server using http.createServer, passing a callback function that defines the server's response to client requests. The server is set to listen on port 3000 of the local host, 127.0.1. When a request is received, the server responds with a status code of 200 and sends a plain text message, "Hello World." This example illustrates the basic interaction between a host, the machine running this Node.js code, and a server, the software handling HTTP requests. Deploying to cloud services, Heroku, AWS, Azure. Heroku is a popular cloud platform as a service that enables developers to build, run, and operate applications entirely in the cloud. Deploying an application to Heroku involves using Git for version control and Heroku CLI for interacting with your Heroku account. First, log into Heroku CLI on your machine. Initialize a Git repository in your project folder if you haven't already. Set a remote for Heroku pointing to your app's name on Heroku. Add all files to Git, commit with a message, then push the code to Heroku master branch. Heroku will detect the push, build, and deploy your application. Continuous integration, continuous deployment, CI/CD. Continuous integration, CI, and continuous deployment, CD, are practices in software development designed to improve code quality and facilitate automation in building, testing, and deploying applications. CI involves automatically integrating code contributions from multiple developers into a single software project frequently. CD automates the delivery of this integrated code to selected infrastructure environments. The following example demonstrates a basic CI/CD pipeline configuration using GitHub Actions, a popular tool for such processes. In this CI/CD pipeline configuration using GitHub Actions, we see a simple workflow defined under the CI/CD pipeline name. It triggers on every push to the repository, executing jobs on the latest Ubuntu environment. It outlines steps for checking out the code, setting up Node.js, specifying version 14, installing dependencies, and running tests. The final step, conditional on the push being to the main branch, deploys the application. This example encapsulates both continuous integration, by integrating and testing code, and continuous deployment, by automating deployment to production. Environment variables and configuration. In full-stack applications, it's essential to manage environment variables and configuration settings in a way that separates development settings from production. This practice enhances security, allows for easy adjustments, and keeps sensitive information, like database passwords or API keys, out of your codebase. Here's how to use environment variables in a Node.js application. The code snippet first requires the .env package, which loads environment variables from a .env file into process.env, making them accessible throughout the application. Then it retrieves the database password environment variable. This value could be different between development and production environments, enhancing both the security and flexibility of the app's configuration without changing the codebase. Scaling applications. When your application grows in terms of traffic and data volume, simply running it on a single server is no longer sustainable. This leads us to the concept of scaling, which can be horizontal, adding more machines, or vertical, adding more power to existing machine. In this example, we'll focus on a simple scenario of horizontally scaling a Node.js application using a load balancer. The provided code outlines a basic HTTP server in Node.js, designed to respond with "Hello World" for any incoming request. In a scaling scenario, multiple instances of this server may be initiated across different machines to spread out the load. A load balancer would be positioned in front of these servers to distribute incoming traffic evenly, increasing the application's ability to handle large volumes of requests. This setup exemplifies horizontal scaling, where capacity is added by integrating more instances rather than upgrading the current hardware. It's crucial for real-world applications that aim to serve millions of users without degrading performance. Load balancers and reverse proxies, Nginx. In the context of web applications, a load balancer distributes incoming network traffic across multiple servers to ensure no single server becomes overloaded, thus improving reliability and performance. Nginx, a powerful tool, can be used both as a load balancer and a reverse proxy to direct client requests to the appropriate server backend. This setup enhances the scalability and availability of web applications. In this Nginx configuration, upstream defines a group of servers, myapp, that will handle requests. Two servers, server1.example.com and server2.example.com, are included in this group. The server block listens on port 80, the default HTTP port, and uses the location/directive to specify that all requests should be forwarded to the myapp group. The proxy pass directive tells Nginx to distribute incoming requests to the servers defined in myapp. This setup enables basic load balancing and reverse proxy functionality, distributing client requests between server 1 and server 2 to balance the load and ensure high availability. HTTPS and SSL certificates. Implementing HTTPS ensures that the data transfer between the user's browser and the server is encrypted and secure. SSL, Secure Sockets Layer, certificates are the technology behind creating this secure connection. Here, we will look at a basic example of configuring an Express.js server to use a SSL certificate for HTTPS. This code snippet demonstrates how to set up a basic HTTPS server with Express and Node.js. First, it requires the necessary modules: Express for the server framework, HTTPS for creating HTTPS servers, and FS to read the SSL certificate files from the file system. The createServer method of the HTTPS module takes an options object containing the SSL certificate, cert, and the private key, along with the Express app. The server is then set to listen on port 3000. This setup ensures that any data transmitted to and from the server is encrypted, improving the security of user data. Web Security Basics, SQL Injection, XSS, CSRF. SQL injection is a web security vulnerability that allows an attacker to interfere with the queries that an application makes to its database. It can allow an attacker to view data they are not normally able to retrieve. This can include data belonging to other users, or any other data that the application itself is able to access. A successful SQL injection attack can even allow an attacker to modify and delete data in the database. In the code snippet above, the application constructs a SQL query directly using user input from username and password without any validation or escaping, making it vulnerable to SQL injection. For example, an attacker could enter a username of or1=1, which could potentially allow unauthorized access. To prevent SQL injection, one should use parameterized queries or prepared statements provided by the database management system. Performance optimization, lazy loading, code splitting. In modern web development, improving page load time and overall performance is crucial. Two key techniques for achieving this are lazy loading and code splitting. Lazy loading refers to loading resources only when they are needed, rather than all at once. Code splitting involves splitting your code into smaller chunks, which can then be loaded on demand. In this React example, we demonstrate lazy loading with code splitting. The React.lazy function allows us to dynamically import a component /lazy component, which means it will only be loaded when it's required, not when the app first loads. This drastically reduces the initial load time. The suspense component wraps the lazy loaded component, providing a fallback content loading to display while the lazy component is being loaded. This approach optimizes performance by reducing the size of the initial JS bundle loaded by the browser, leading to faster page load times and a better user experience. Cross-origin resource sharing, CORS. Cross-origin resource sharing, CORS, is a security mechanism implemented by web browsers to prevent malicious websites from accessing resources and data from a different origin without permission. An origin is defined by the protocol, domain, and port of a URL. CORS allows servers to specify who can access its resources and under what conditions. This line of code is often found in HTTP response headers. When a server includes this header in its response, it indicates that the server is willing to share its resources with any origin. The asterisk symbol acts as a wildcard, meaning that requests from any origin will be accepted. This setting can be risky and should be used with caution, as it allows any website to make requests to the server. In production environments, it's better to replace the wildcard with a specific domain to limit access to known trusted sites. API design and documentation. Swagger, Postman. An essential part of modern web development is designing and documenting APIs in a way that's both human and machine readable. Tools like Swagger, now part of the OpenAPI specification, and Postman play crucial roles here. Swagger helps in defining API structure, whereas Postman is utilized for API testing and exploration. Let's see a basic example of how Swagger documentation for a simple API might look. The provided code is a basic Swagger document that defines a simple API for retrieving a list of users. It starts by specifying the Swagger version 2.0 and then goes on to detail the basic information about the API under info, like its title, description, and version. The host, base path, and supported schemes define where the API is hosted and how to access it. The path section outlines the available endpoints, in this case, /users for GET requests. Each endpoint's details, such as the summary, description, output type, produces, and possible responses, are described, illustrating how Swagger provides a comprehensive, readable API definition. Microservices architecture. Microservices architecture is a method of developing software systems that are made up of independently deployable modular services. Each service in a microservices architecture can run a unique process and communicate through a well-defined, lightweight mechanism to serve a business goal. The provided code snippet demonstrates a basic Express.js application representing a simple microservice. In this architecture, each service runs in its own environment and communicates over the network, enabling a resilient, scalable system. The application listens on a specified port and responds with "Hello from microservice" to HTTP GET requests to the root URL. This illustrates the principle of microservices, where each service performs a single function and can be deployed independently. Containerization and virtualization, Docker, Kubernetes. Containerization is the process of packaging software code its dependencies, and system tools into a single container, while virtualization creates multiple simulated environments from a single physical hardware system. Docker is a popular containerization tool, and Kubernetes is a container orchestration system for Docker. This Dockerfile snippet begins with specifying the base image from Node 14, which is a pre-made image containing Node.js version 14. The work_dar/app sets the working directory inside the container. Copy copies the application code into the container. Run npm install installs the dependencies defined in package.json. Lastly, command npm start specifies the command to run the application. Docker packages the application with everything needed to run it consistently across any environment. WebSockets for real-time applications. WebSockets provide a way for web servers and clients to exchange data in real time without the overhead of traditional HTTP requests. They are ideal for applications requiring continuous data exchange, such as chat applications, live sports updates, and real-time analytics. In this example, we'll establish a basic WebSocket connection between a web server, Node.js, and client, HTML JavaScript. In the server-side code, Node.js, we create a WebSocket server using the WS library, listening on port 8080. When a client connects, the connection event triggers, setting up a message handler that logs any received messages to the console and sends a greeting message back to the client. On the client side, HTML JavaScript, we initiate a connection to the WebSocket server. The onMessage event is set up to log messages from the server, and upon successfully opening the connection, onOpen event, the client sends a greeting message. This basic interaction demonstrates real-time communication between the server and client, foundational for building more complex real-time applications using WebSockets. Serverless architectures. Serverless architectures allow developers to build and run applications without managing servers. The cloud service provider automatically manages the server infrastructure, scaling resources up or down as needed. This model lets developers focus on writing code and deploying functionalities via functions, which are units of deployment and execution in a serverless environment. The code snippet demonstrates how to invoke an AWS Lambda function using the AWS SDK for Node.js. It shows the instantiation of a new AWS Lambda object, the setup of parameters including the name of the Lambda function and the payload to send, and the invocation of the Lambda function with lambda.invoke. If the invocation is successful, it logs the function's response, otherwise it logs the error. This example illustrates how serverless functions can be executed without provisioning or managing servers, relying instead on cloud infrastructure to handle execution and scaling. Progressive Web Apps, PWAs. Progressive Web Apps, PWAs, are a type of application software built using common web technologies, including HTML, CSS, and JavaScript, which function as a traditional mobile app. The key to PWAs is the use of service workers to enable capabilities such as working offline, push notifications, and background data syncing, along with manifest files for adding the web app to home screens on mobile devices. The code snippet demonstrates the registration of a service worker, which is a foundational step for creating a progressive web app. The if statement checks if the current browser supports service workers. Upon loading the window, an event listener triggers the registration of the service worker using navigator.serviceworker.register/service-worker.js. Successful registration means the browser can now cache assets, handle offline functionality, and interact with push notifications, bringing a native app feel to the web application. Full-stack project planning. Full-stack project planning involves outlining the components, functionality, and structure of both the front-end and back-end of your application. It's essential to consider project requirements, design patterns, and technologies that will be utilized. Planning phases typically include defining the project scope, selecting technologies, designing the architecture, and breaking down tasks. The code represents an example of a simplified project plan in a full-stack development context. Scope outlines overall project goals, technologies lists the tech stack, front-end, back-end database, architecture specifies the design pattern, model view controller, and tasks break down the project into manageable components. This planning stage is crucial for efficient workflow and project success. Integrating front-end with backend. Integrating the front-end and backend is a fundamental aspect of full-stack development. It allows the UI, user interface, to interact with the server and database, creating dynamic and responsive web applications. This process typically involves making HTTP requests from the front-end to endpoints exposed by the backend. For simplicity, we'll demonstrate this with a basic example where the front-end fetches data from a backend server. In the given code snippet, we're using the fetch API in the front-end to make a GET request to a backend endpoint, h/localhost 3000's data. The request is made asynchronously, and once we receive a response, we try to parse it as JSON with response.json. After successfully parsing the response, the data is logged to the console. If there's an error in fetching the data, such as the server being down, it's caught and logged as an error. This example succinctly illustrates the basic pattern of how front-end applications communicate with the backend, fetching data as needed to react and display to the user. Using version control in teams. In full-stack JavaScript development, version control is a fundamental practice that allows multiple team members to work on the same codebase without conflicts. It involves tracking and managing changes to software code. One of the most popular version control systems used by developers is Git. When used in teams, Git enables collaboration through features like branches, merges, and pull requests. Here's a basic example of how a team member might create a new branch, commit changes, and push the branch to a remote repository for others to access. Coding best practices. Indentation is crucial for improving the readability of the code, allowing developers to understand the structure and flow at a glance. This example demonstrates a consistent indentation practice. In this code, we use a consistent 4-space indentation at each level, making the structure clear. The function declaration starts at the leftmost, with the body indented. Inside the function, the console.log and if statement follow the same indentation rule, making the code hierarchy easy to understand. Adopting a consistent indentation style, such as 4 spaces or a tab, across your project helps in maintaining readability and reducing the chance of errors. Code reviews and collaborative coding. Code reviews and collaborative coding are essential practices in the development process, fostering better code quality and team cohesion. Code reviews involve examining source code by colleagues to spot mistakes, ensuring adherence to coding standards, and sharing knowledge across the team. Collaborative coding, or pair programming, is when 2 developers work together on the same codebase, one writing code, while the other reviews it in real time. In this simple JavaScript function example, add AB, one developer could write the function to add 2 numbers, while another reviews it. The process involves checking for syntax errors, ensuring the code uses best practices, and possibly even optimizing the code. The reviewing developer might suggest using more descriptive variable names or adding comments for clarity. This collaborative effort not only improves the code's quality, but also facilitates knowledge sharing and mentorship among team members. Building portfolio on GitHub. Creating a professional portfolio on GitHub is crucial for showcasing your full-stack JavaScript projects. It serves as a way for potential employers or collaborators to assess your skills and works. This involves creating a compelling README file for each project. This markdown format helps in structuring your project READMEs for clarity. The project title should be engaging and reflective of what the project does. The overview section briefly describes the project, its objectives, and the technologies involved. Features delve into the project's functionality, while installation and usage provide concise steps for setting up and using the project. The contributing section offers guidelines for others who wish to contribute to the project, encouraging collaboration. Lastly, the license section informs users about the legal permissions regarding the use, modification, and distribution of your project. Adequately documenting your projects in this manner makes your portfolio more professional and accessible. Documentation and README files. Creating a comprehensive README file is crucial for your project's success. It introduces your project, guides users on how to use it, and contributions. Let's create a simple README structure. The code block provides a template for a README file, starting with a title and a short description. The installation section guides the installation process, here exemplified by a simple npm command. The usage section explains how to incorporate and use the project, demonstrated with basic import and usage of a fictional project. Contributing and license inform about contributing guidelines and the project's legal license, respectively. Formatting is done in Markdown for GitHub compatibility, showcasing headers, code blocks, and instructions clearly.